Let's have a look at the next question. Figure 5.1 shows a saucepan of boiling water on an electric hot plate. As time passes, thermal energy is constantly supplied to the water, but its temperature remains at 100 degrees Celsius. State two ways in which this boiling differs from evaporation. In boiling, the exchange of energy happens throughout the entire layer of the liquid, whereas in evaporation, energy transfer just happens on the topmost layer of the liquid that is open to, or that is in contact with, the atmosphere. Another difference between boiling and evaporation is that boiling is not affected by the area or the surface area that is open or in contact with the atmosphere, whereas evaporation is. Whereas boiling produces bubbles, evaporation does not produce bubbles. Moving on to part B, explain in terms of water molecules what happens to the thermal energy supplied to the water as it boils. Now, as the water boils, or as water is supplied with energy, the energy transfer occurs between different layers of water molecules, and consequently, this energy that is supplied helps break the intermolecular bonds or forces. Break the intermolecular bonds or forces. And as a consequence of this, the molecules separate or become separated and they move farther apart. Moving on to the next part, describe an experiment to measure the specific latent heat of steam. You may include a diagram. Now let us understand what specific latent heat first is. Specific latent heat for steam or any material is defined as the amount of energy required per unit kg of a substance to change the state of the substance from liquid to gaseous or gaseous to liquid. Now, to confirm or to perform this experiment, we are going to need a measuring cylinder. We are going to require a thermometer, as specific latent heat has something to do with the change of state without a change in temperature. So it is important for us to note down the changes in temperature, if any. We also need a heat source. We could use a kettle for this, a heat source. So we could use a kettle for this. Now, we perform the experiment by pouring down a measured quantity of water using a measuring cylinder within a pan, and this pan is then boiled. Now, this boiling, which is done using a kettle, is performed under a controlled environment where the steam that is produced due to boiling and due to evaporation is not allowed to escape. All the while, a thermometer is placed to note down the change in temperature. We notice that when an experiment is performed under such a controlled environment, there will come a time where the entirety of the liquid in the pan, which is being boiled, will convert into a gaseous state. And it is at this point that the thermometer will start to show a rise in temperature as the entirety of the water has been converted, or the entirety of the energy has been used to convert water to gas. And now further energy that is provided is used to increase the temperature. It is at this point that we make a note of the energy that is provided. And we also make a note of the mass of water that was poured into the pan using a measured cylinder. We know that specific latent heat is given by the formula energy consumed divided by mass. By using this relation, we can find out the specific latent heat of either fusion or specific latent heat of either evaporation or condensation for steam.